All right, so this question is January 2019, question 9. All right, so the topics we are doing are circuit theorem, spatial geometry, and sine rule, cosine rule, and bearing. The question says, the diagram below not drawn to scale shows a circle. The points P, Q, R, and T and V are on the circumference. We're told that QRS is a straight line. Angle PVR is equal to 75 degrees, and angle TRS is equal to 60 degrees. We're asked to determine the value of each of the following angles, show detailed working where necessary, and give a reason to support your answer. So the first angle we're asked to determine is the size of angle PTR. So let's identify the angle. Angle PTR is this angle here. So everybody should remember, when 3 letters are used to reference an angle, the angle is always at the letter in the middle. When 3 letters are used to reference an angle, the angle is always at the letter in the middle. All right, so the angle at T, well, this would be my answer. Angle PTR is equal to 75 degrees. And then it says, so show details where necessary and give a reason for my answer. Well, what is the reason? This angle here, these 2 angles are 75 degrees. They are, so they are angles in the same segment. So now, how do I know that? Now, if I had a line from a straight line from P to R would be what we call a chord. That's a chord. Now, a chord divides a circle into segments. So up top, you'd have the major segment, and below the chord, you'll have the minor segment. Now, the angle at V and at T, they have the same starting point on the circumference and the same ending point on the circumference. And they are both formed at the circumference in the same segment. So both the angle at T and the angle at V both start at P and end at R, and they are formed at the circumference in the same segment. The 2 angles are equal, they are called angles in the same segment. So angle PTR is equal to 75 degrees. Why? They are angles in the same segment. I notice here that the examiner give what? About 3 lines to explain something. I don't know. So if you wanted to, you could try and explain it. If you wanted to write something in words, angle, I believe what I wrote is sufficient. PVR, angle PVR, and angle PTR are angles in the same segment and angles in the same segment are equal. All right, as I said, I believe what I wrote above it was sufficient. But if you wanted to, because the one write out 3 lines, writing something in it wouldn't hurt. All right, let's move on to the next part of the question. Next, we're asked to find angle TPQ. So let's go back and identify it. Angle TPQ all right, going to the wrong direction. All right, let me erasing this. Angle TPQ, that's this angle here. Angle TPQ. What I want you to notice is that PT or TPQR is a cyclic quadrilateral. TPQR is a cyclic quadrilateral. Now, a cyclic quadrilateral is a quadrilateral in which all four vertices are touching the circumference. So TPQR, that's this quadrilateral here, is a cyclic quadrilateral. Now, angle TRS, that's this angle here, the 60 degrees, is called external angle of a cyclic quadrilateral. Now, the exterior or external angle of a cyclic quadrilateral is equal to the opposite interior angle. If this angle here is 60 degrees, the angle here is also 60 degrees. Why? Because the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So let's go back and answer the question. So I'm going to say angle TPQ is equal to 60 degrees. Then I would write the exterior angle cyclic quadrilateral is equal to the opposite interior angle. The exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. All right, so if you want to spell it out now, what did we say? We have what? TRS, angle TRS, which is equal to 60 degrees, is the exterior angle of a cyclic quadrilateral, which is TPQR. Angle TPQ is the opposite interior angle. The exterior angle is equal to the opposite interior angle. Ladies and gentlemen, the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. Lastly, we're to find obtuse angle. Now, I think what obtuse means what? More than 90, but less than 306, less than 180 degrees. Obtuse angle POR, where O is the center of the circle. So let us try and get a visual appreciation of that. Let's erase some of this information here. So we know that this angle here is 75 degrees. This angle is 60 degrees. Now, I'm going to put a point and call it O. That's the center. This is PO. Try and draw the best straight line to it. That's POR. This is the angle the examiner wants us to find. All right, POR. Now, I know that this angle must be 150 degrees. Now, please note, I drew that to get a visual appreciation of it. The examiner did not put the point, the center of the circle on the diagram. So I had to include it, all right? And now, why is that angle 150 degrees? Now, you see this angle here at 75? Please notice that the angle at the circumference, which is 75 degrees, starts at P and end at R. The angle at the center, which is 150, start at P and end at R. So the angle at V is called the angle at the circumference. The angle at O is called the angle at the center. Now, what are their characteristics? They both have to start and end at the same point on the circumference. One goes to the what? Circumference, and the other goes to the center. The one at the circumference is called the angle at the circumference, and the one at the center is called the angle at the center. The angle at the center is equal to 2 times the angle at the circumference. So then I can go back and answer the question and say to the examiner that angle POR is equal to 75 times 2 is equal to 150 degrees. And I could say angle at center is equal to 2 times angle at circumference. The angle at the center is equal to 2 times the angle at the circumference. I believe what I wrote was enough, but if you wanted to, angle P VR, which is 75 degrees, is the angle at the circumference. Angle POR, which is 150 degrees, is the angle at the center. Now, angle at center is equal to 2 times angle at circumference. All right. So I'm going to stop the video here and then I'm going to record the next one. I don't want the video to go on for too long.